안녕하세요. AWS 서밋 온라인 코리아 둘째 날에 오신 것을 환영합니다. 저는 AWS에서 솔루션스 아키텍처 매니저로 근무하고 있는 김용우라고 합니다. 오늘은 자바의 아버지이자 AWS에서 디스tinguished 엔지니어로 근무하고 있는 제임스 고슬링을 모시고 서밋 온라인 둘째 날을 열어보도록 하겠습니다. Hi James, it's great to have you with us today. Can you say hi to Korean customers and also introduce who you are and what you do in AWS?
Hello, everyone. This is James Gosling. I'm really thrilled to be here, and thanks all of you for coming to this summit. You'll be learning an awful lot of interesting material, and my only regret with this summit is that I can't be there with you. So I am what AWS calls a distinguished engineer, which means that I work fairly broadly across the company. I get pulled into projects to help them out, give them advice. Mostly, I've been working on the Greengrass project. My expertise over the last several years has mostly focused on embedded devices, the IoT world. It's an area that I've found really, really exciting, and I think for folks in Korea who are manufacturing all kinds of interesting devices, this is a pretty exciting world too. So thanks again for inviting me, and it's going to be a really nice show.
Thank you for your warm greeting, James. I know it's been about 3.5 years since you joined AWS. Can you please share some of your key observations or some interesting experience along with your journey?
Well, the first time I used AWS was like 15 years ago, when it was nothing much more than EC2 and S3. It's just been amazing to watch the growth of AWS, both in like number of services and the scale of those services, and how they can help customers in so many ways. If you need to reach billions of people, it's really amazingly straightforward to do on AWS. I mean, there's so many video streams and text messages and applications all running concurrently, talking to people all over the world all at the same time. It's just an amazing place to be and watch.
Thanks. I know you've been working in engineering role focusing on technology for the most of your career, even in AWS for now. And I really like to know, how do you maintain your focus and passion for technology? What keeps you motivated?
The thing about computing that keeps me motivated is that it's really a tool, right? It's a tool that gets used in a lot of really diverse situations. And, if I start getting bored with one area where computers are being used, there's always another, and then another, and then another. I mean, the breadth of application areas is huge. And I find it just impossible to be bored. The problem I generally have is the opposite of that, which is that there is so much happening and so much to look at that is just really, really entertaining and intriguing.
Since you are known as the father of Java, I'm sure a lot of our customers would like to ask this question to you. What is the state of the union of Java, and where do you think Java is headed?
Java is doing astonishingly well, in a way that I find just hard to believe. And, it's not just Java, it's really, in my mind, Java isn't as much the language as it is the JVM. And this explosion of languages that run on the JVM, things like Scala and Clojure and Kotlin and Groovy, and there's just so many of them, and they're all really, really cool. And they really keep the place alive, and just the mind-numbing collection of APIs and libraries. And one of the places that I feel has got to be a real hotbed for growth is that, way back when this all started, Java was intended to be a language for writing Internet of Things applications. That forced a lot of the issues in Java around security. And in IoT apps that I've written in Java, it's worked out really, really well. And I'd love to see more growth of that. People, when they're building IoT applications, they tend to build pretty straightforward things, so you don't need tools that are really sophisticated. But the sort of things that are happening in IoT these days are getting really, really up there. And it needs a sort of a different leap in tooling.
Coming back to AWS, now the cloud became the new normal as a platform for running various application services. From your perspective, what are the biggest advantages that AWS Cloud has to offer for developers?
There are a lot of different advantages, but if I wanted to pick like two advantages, the biggest ones are in some sense the obvious ones, namely scale. If you want to build a system that has to be visible to, thousands or millions of people, building an infrastructure like that, in your own data center is genuinely hard. And AWS has all the tools for that. And sort of the flip side of that is, what does it take to actually run a 24/7, never goes down service? And for most people, that is a very painful and expensive operation that takes quite a while to learn how to do. To keep all of the different components, the databases, the storage areas, the business logic servers, all of that, everything has to be running. And that's really not a part of what your business is trying to do. In some sense, it's kind of wasted effort for you because it's something that everybody has to learn. But that is, the absolute center of what Amazon does, right? Is we do, I guess the Amazon phrase for that is undifferentiated heavy lifting. The stuff that everybody has to do to make sure that their websites stay up is stuff that they mostly don't have to worry about because we do.
Thank you. You briefly mentioned that you are working on Greengrass project earlier. Can you please elaborate it a little further? And also, can you please share AWS vision or direction for the edge computing?
For the past couple of years, I've been working on the Greengrass project. In building IoT applications, there are pain points that hit every developer. The device has to be secure. It has to be able to be updated over the air. It has to be robust. It has to be able to deliver telemetry. It has to be able to be managed and deployed at scale. These features are hard to build, hard to test, and only differentiate an IoT product if they're done badly. And there is a wide wide range of variation from one IoT application to another. So flexibility is absolutely key. So Greengrass is a collection of software components that run on a device, along with a set of services in the cloud. At the center of the software that runs on the device is something that we call the nucleus. And it's fundamentally a lifecycle manager for the components. It understands how to install, start, run, do some error recovery, and just about everything else is a component. So even over-the-air update is a component. You can do over-the-air updates in a wide variety of ways, curling files. You can use apt-get, you can use yum, you can use Docker. It's really, really flexible. We've got components to deal with some of the more popular ones. But then that goes along with ways to deliver telemetry to the cloud, ways to manage the devices at scale. So whether you've got a dozen devices or 1 million devices, you can give them all commands to do things like upgrade to version 7, or go into power saving mode, or you can slice your fleet up into subfleets and individually give them commands. And you can have intermittent telemetry that happens, once a day, once an hour, or you can have high volume telemetry that will, flood a kinesis stream. And all of these pieces, they're just components. You get to pick and choose. So the stuff that you don't need, you don't have to pay for. You don't have to pay for in RAM. You don't have to pay for in performance. All of it, of course, is open source. So you can, take a look at it and kick the tires and play with it. It's been a lot of fun.
Thanks for sharing. We also have a breakout session ready for Greengrass for those who like to find out more. Just one last question. Is there any technology areas or topics you think is important for the developers these days? And any last words for Korean customers before we wrap up?
So I'm really jazzed about the edge computing these days. I've spent most of my time at Amazon working on edge devices, and Greengrass is a big piece of it. And one way to think about that is that you've got your app that you want to run, whether it's a controller for curtains that opens and closes the curtains depending on how light it is outside, to be able to just do that part of your app, but then be able to add over-the-air updates and security monitoring and telemetry and all of that very, very easily, right? Because a lot of that stuff is things that every IoT app should have. And the world is littered with examples of people who, for instance, security is something that people always overlook. And security is one of those things that, should be one of those things that you just kind of live and breathe, right? You got to pay attention to security. And yet security is very difficult. And, the presence of security isn't a big feature for most things. But the absence of security tends to be a real problem. So we, provide a lot of facilities to enable folks to build highly secure enterprise embedded apps with a lot less fuss and bother.
Thanks a lot, James. It was a great pleasure meeting with you. I bet many Korean customers appreciate your virtual visit.
Well, I appreciate all your questions, and I certainly wish I could be there.
Thanks again for your visit, James. 자, 이어서 AWS 아태 지역 신기술 담당 총괄인 올리버 클레인에게 마이크를 넘겨서 AWS의 주요 기술 트렌드에 대해서 들어보도록 하겠습니다. Hey Olivier, are you ready?
Thank you, Kevin and James, for this insightful conversation of looking at the evolution of Java and how we moved to the edge and really looking into how things have changed over the years. And this is the second part of our keynote here. I really want to focus on looking into how do we modernize your technology landscape and how can AWS help. As Kevin mentioned earlier, I'm Olivier Klein. I'm the Chief Technologist for AWS here in Asia Pacific. Now, if we talk about modernizing your technology landscape, though, we really want to focus on driving specific business outcomes. We want to improve our customer satisfaction, for example. How can we use data and machine learning to maybe build personalized experiences? How can we build modern applications in a manner that they are more scalable and real responsive? How can we move to a scenario where we have a faster time to market in the way we develop our software and achieve workforce productivity, and at the same time mitigate risk, create scalable, secure systems on top of the AWS platforms? And then, of course, at the same time, look into how some of these modern application architectures can help us reduce cost, automate and reduce waste, allowing us to have bottom line savings and top line growth and drive innovation. But let's kick it off with something first. Take the following number, over 150 million. What could that be? Well, over 150 million is the amount of deployments that we had, code deployments, in the whole of Amazon last year. To put that into perspective, that means every second we have 4.5 deployments in average. That's every 0.21 seconds there's a deployment happening across the Amazon platform. That allows us to be fast and agile and innovative. But if you think about it, how does that work? How can we have so many deployments all the time? Well, the key point here is to say, let's build lots and lots of small different teams that allow to work independently on their pieces of code, on their services. We call it the two-pizza team strategy. Why two-pizza team? Well, we build small cross-functional teams. So it's not just a team of developers, a team of database administrators. No, it's small cross-functional teams that take care of one specific part of a product, of a service. And they're small enough so that they can quickly iterate on their own and quickly deploy on their own without relying on a lot of other people. But the team wouldn't be too large that two pizzas could feed the team. These would be two American-sized large pizzas here, but that's basically where the two-pizza team strategy comes from. In addition to that, you also own and run what you build. We found that that greatly improves the way developers build their code, because if you build it and you also need to run it and you get paged if there's a problem, you obviously want to build better. As Werner Vogels always says, our CTO, you build it, you run it. Now, with that in mind, though, this really brings us to the modern way of designing and building application and data architectures. And if you look at the following diagram here, we're looking into how can we move from this traditional approach of, let's say, maybe a big monolithic application and breaking it up into these smaller microservice architectures. That's exactly what that two-pizza team strategy is intended to do. But also not just application architectures. How about data architectures? Move from one central big database to decoupled, purpose-built data stores. Look into how can we automate my software delivery that it automatically completely rolls out, complete CI/CD pipeline. Have operations that go from self-managed to fully managed by AWS. And of course, look into how we can move from a security posture of central gatekeeping, you cannot do this, cannot do that, rather enabling things by building in guardrails into that new modern application architecture. Now you're going to say, okay, that's great, but if I build something new, I can obviously adopt these new modern application architectures, but what about my existing systems? Do I need to refactor everything? And this is really what we refer to as the 7 Rs, because for your existing workloads, it might make sense for some of them to retire them, some of them maybe to say, we want to retain its current traditional format because I want to focus on other bits and pieces. Some others I might want to just lift and shift. I want to rehost or relocate from on-premises onto your AWS platform. Some of it I might want to repurchase through our partners, through SaaS solutions. Or maybe I want to re-platform bits and pieces of it, like re-platform the database, for example. Again, we provide you flexibility and choice so that you can take a step-by-step approach of slowly modernizing bits and pieces of your application landscape. And let's have a look at how some of our customers have done that. Take, for example, Coca-Cola. They took over 600 different workloads that were Unix-based, moved them to Linux and to AWS in under 14 months, achieved not only 40% operational cost savings, but they cut down processing times from 36 hours to 10 seconds. Or take FINRA, the Financial Regulatory Authority in the United States. 500 billion stock trades that they need to validate every single day. They moved the entire Hadoop cluster to complete serverless architecture in AWS in just 3 months, increased cost efficiency by up to two times. Or Samsung. Samsung recently moved or migrated 1.1 billion users across 3 different continents that they had on legacy Oracle databases to newer, modern databases such as Amazon Aurora with the help of our database migration service. Achieved and reduced the monthly database cost by 44%. McDonald's built and launched home delivery in less than 4 months, scales to 20,000 orders per second with less than 100 millisecond latency with these kind of new application architectures. Or Capital One that found that building out new application and infrastructure with AWS, they have reduced the time by up to 99%. That's really the power of modernizing your application landscape. But what are our customers asking us for? They say, hey, I want to focus on building what's core to my business. I don't want to focus on managing and building and racking, stacking infrastructure. I don't want to care about how things scale. They should scale quickly and seamlessly. And security should be done by design and in isolation. And my cloud provider, AWS, should help me do that. And when we say modernization, that is exactly what it is about. Looking at what's the right kind of service that help you reduce the operational overhead that you need to have or that you have had when you ran on-premise. Again, there's a certain level of modernization, as you can see here. Maybe you want to just move to infrastructure services, virtual servers like EC2 or VMware Cloud on top of AWS. Or maybe you want to move further up to platform services, all the way to potentially cloud-native services, such as AWS Lambda or Amazon Athena, where all you focus on is building your application code, and the rest is taken care of by AWS. Now, in addition to that, we also give you flexibility to run your application, of course, in the AWS regions, but whenever it is required for specific latency-sensitive applications or specific scenarios where some pieces and bits and pieces of your code needs to run on-premise or at an edge location, we provide you with services across the board, from all the way on AWS regions to all the way to your own infrastructure at the edge. Let's say you want to run your code maybe in a 5G cell tower. AWS Wavelength can help you do that. With AWS Outposts, you get access to the same infrastructure that AWS is using, but have it running on your office of your own premises. Let's say if you want to run your containers and you like our Amazon EKS, Kubernetes service, or ECS, the container service, and you say, I want to run some of these containers also sometimes on-premise or at the edge. With Amazon EKS and ECS Anywhere, you have one single pane of glass of an AWS region where you can deploy your container in the region or at your outposts or on your on-premise on your own infrastructure, even on hardware. And of course, also services such as AWS IoT Greengrass or AWS Snowball Edge allow you to run your code at the edge, resynchronize with the cloud, and even have ways to move data effectively back and forth. In addition to that, we also want to give you flexibility and choice of what are the underlying virtual servers or capabilities that you require for your workloads. We provide you with the broadest and deepest platform here. And no matter if you need general purpose instances or compute or memory intensive instances, or you need accelerated computing or maybe high instance storage or high memory footprint, we have over nearly 400 different instance types for virtually any workload that your business needs. And again, also in that regard, we provide you with the broadest choices of processes and architectures that you want to run on. Maybe you want to run on Intel Xeon Scalable processors. Maybe you want to use the latest Habani Gaudi Habana Gaudi-based AI processor of Intel. Maybe you run around on AMD on the EPYC processors or the latest GPUs. Or maybe you want to use AWS Graviton 2, which is a processor that AWS specifically built. It's an ARM-based architecture that can reduce your cost of running workloads up to 40%. Or AWS Inferentia and Trainium, which are AI and machine learning specific processors. NVIDIA GPUs, or Xilinx FPGAs for custom hardware acceleration. And by the way, we're also the first cloud provider that is now offering macOS capabilities. So if you develop for OS X or iOS and you need capabilities here, we now provide you with that choice too on top of our platform. Now let's stick with modernization though here. Apart from having a lot of choice and having the ability to choose the level of modernization, well, if we modernize, refactor some of it, but some of it gets re-platformed, how do we stitch that all together? And that's really where the idea of APIs come in. So all these different modular services that you now build out, APIs allow you to work independently on that service, on that microservice, for example, and then contact other services. But in addition to that, another great practice is to say, I want to build an event-driven architecture. So as things happen in my microservice, I put out events and other services can pick it up. Build a more resilient and reliable application architecture, and we're going to dive into that in just a bit. But what about running your code, right? There's services such as AWS Lambda that allow you to run your code fully managed in an AWS environment. But one great way to package everything up is the idea of containers. So if we have containers, we can package up our code and all the different kind of dependency, have it in a container, deploy it out, and run it wherever we want. Wherever we want. What do I mean with that? Well, you have the option to run it on-premise. With AKS or ECS Anywhere or Outpost, you run it with the same strategies, the same services on-premise, then you run it in your AWS environment, where of course, again, you have full choices of running it either way managed or on EC2, or you run it at the edge, maybe on your 5G cell towers with wavelength or local zones. But the other idea is to run it fully serverless with the help of Fargate. What does serverless actually mean? Well, serverless is the idea of saying, okay, let's step away from physical machines to virtual machines to containers to completely serverless, meaning everything scales automatically to the amount of load that you have on your system or the amount of users that are using it. Fault tolerance is built in, it spans across multiple availability zones. But here comes the best part. You only pay for what you use. In AWS Lambda, you only pay for the milliseconds of execution time of your code, so that you can focus on your business value, on building your code, rather than thinking about scaling and securing and maintaining things out. And now this is not just on the compute level. This spreads across many different areas. So let's say if you need a serverless database, Amazon Aurora Serverless gives you a serverless relational database. Amazon DynamoDB gives you a serverless NoSQL database. Amazon S3 gives you serverless storage. And the same goes for messaging, analytics, machine learning. We give you a full spectrum of services that span across your entire architectures that allow you to go more and more serverless, meaning you can offload a lot of the operational responsibility to AWS. Again, you have choice and flexibility of what you're choosing, but the more you move towards that serverless architecture, the less operational overhead you have. And let me give you a very specific example of a customer right here. Take, for example, BBC, which runs a news website here. That website is rendered using serverless microservices on top of AWS. That's tens of millions of worldwide users and over 2,000 Lambda functions per second that gets invoked. But why is serverless really useful here? Well, think about the nature of a news website, right? You have an article, the article maybe goes viral, people post it all over social media, your traffic goes up like crazy. And maybe over some time, the traffic drops back down to way less. That's a perfect example of where serverless is really useful, because not only does it automatically scale, to the amount of users that are now looking at that article, but you only pay for the milliseconds of execution time of that website rendering when it was required. That's the power of serverless, allowing you to reduce that operational overhead. Now, I mentioned event-driven architectures allow us to drive reliability and scalability. What do I mean with that? Well, the first idea is to say, when I have these different microservices or services as general, event routers allow me to abstract away producers and consumers. My service basically places an event into an event bus, and then other services can pick it up. So that allows that abstraction. So I don't need to know exactly how I call your API, for example. But it also allows for responsive design with the help of asynchronous events, right? Maybe you have a website, it renders, now you place an order, now when the event is put down on the bus, my website already renders the response back, and down the line, other services pick up and maybe treat and process the order. That's also good for reliability because we can buffer and store those messages. So if some parts of our services break down, we can degrade the performance, but we can pick it up later on because we have a buffer, a message buffer here through the event-driven architecture. And now you're going to say, hey, Ollie, that's great, but not all of my systems are microservices. Not all of my systems are SaaS platforms. Now, the good news is if it's microservices or SaaS platforms or you refactor, you build in the modern way, Amazon SQS, SNS, and EventBridge can greatly help to build these event-driven architectures out here for you. But what if you have a hybrid setup? What if you have some of your legacy platforms on-premise maybe, or some of your CRM system or ordering front end? Well, with services such as Amazon MQ, which support things like ActiveMQ, RabbitMQ, allowing you to take other legacy systems and have message and event buses that now all interact with each other. And that is the way how you can plug even legacy systems together with some of the latest and greatest refactored or newly built microservices that you're working on. So event-driven architectures allows us to make this much more seamlessly. But let's stick on that SaaS component for a moment. What if we want to have a SaaS integration? Well, Amazon EventBridge makes this really easy if you use some of our SaaS, if you use some of the SaaS platforms that partner with us. Take, for example, Zendesk or Salesforce or Marketo or PagerDuty or Snowflake. Right? If you use those SaaS platforms with EventBridge, you now have a bus layer where you seamlessly integrate into these SaaS platforms with a click of a button, and now you can use your SaaS platforms and have events sent to other parts of your platform that you built on top of AWS, giving you a seamless integration here. Now, as we move more towards this microservice kinds of concepts, service-oriented architectures, I mentioned data architectures also do change. From one centralized database, we move to decoupled, purpose-built databases. Why is that? Well, not too long ago, a relational database was all we needed, right? We stuffed everything in the relational database and we were happy. But a relational database doesn't scale very well if we have high velocity of data or different kind of data structures, or we need to have very specific requirements against the database. So let's say, for example, I want to create a real-time bidding platform, or I have an e-commerce shopping cart, or maybe some social media. Maybe that's where I want to use a key-value NoSQL database. Amazon DynamoDB would be greatly suited for this. Maybe I'm a gaming customer or company, and I want to build a leaderboard. Or maybe I want to do real-time analytics. An in-memory database such as Amazon Elasticache might be a much better choice here. Maybe I run a system of records, or I run a certain supply chain and I need records of that. Then a ledger database might be very useful. Amazon QLDB could help me here. Again, we provide you with a lot of flexibility and choice of databases that we have available for you, fully managed. And the idea here is choose the right database for the functionality that you're building in the service that you're using. Let me give you a specific example here of one of our customers, Duolingo. Duolingo is the world's most popular way to learn a language. Over 300 million total users and 7 billion exercises that are done every month. How does their database landscape look like? Well, they use Amazon Aurora for transactional database structures, like user data. Use Amazon Elasticache, that's in memory, right, for instant access to common words and phrases. But then about how to track progress of what you've learned, which words you learned, etc., where your language exercises are, that's 31 billion items that they're currently tracking. They choose Amazon DynamoDB for that. Up to 24,000 reads and 3,000 writes per second. Right? DynamoDB is made to scale for this kind of high velocity, low latency access on a database. So again, always choose the right kind of data store. Now talking about worldwide or global users, how about distributing that data across. Sometimes it does make sense to bring data closer to an end user and have maybe a replication of your database across geographies, across maybe Americas and Europe and Asia Pacific. Sometimes it might be for regulatory compliance. Sometimes it's for better user experience due to latency. Well, with Amazon Aurora Global Database, you now have a relational database that can be globally replicated into different regions, and you can read and write from those different regions. Or if you run the NoSQL database, Amazon DynamoDB global tables allow you to have replicated tables all across the world for the region of your choice. Same goes for Amazon S3 for your storage needs, cross-region replication. Now, how do you now direct your end user to the right region that has the lowest latency? With Amazon Route 53 and the AWS Global Accelerator, you can now redirect the user to the region with the lowest latency. And of course, maybe use Amazon CloudFront to cache things at our edge locations all across the world. Again, greatly simplifying tasks that previously were quite tough to achieve, of doing that replication and being able to write in different regions across the world and keep it consistent. We now fully manage that for you. Now, talking on databases though, now you're going to say, okay, I have a lot of legacy databases. Maybe you have some Oracle or SQL service lying around, and I want to move to open source. I want to migrate. Can you help me with that? That's the reason we created the AWS Database Migration Service, which allows you to migrate your databases from on-premise or different locations to AWS, but also migrate in between your database architectures. There's an automatic schema conversion. So you can take your Oracle database and maybe move it to PostgreSQL or your SQL Server, move it to open source, and do that data replication with near zero downtime. Take one example here. Another customer of AWS is also Amazon.com. Yeah, we actually need to win their business. So if you look at the broader Amazon.com business, advertising, Prime Video, our fulfillment centers, we had over 7,500 Oracle databases, 75 petabytes worth of data. And a few years ago, we decided to switch it all off. Why? Because it just wasn't very scalable, and it was also very expensive given the punitive Oracle licensing model. So what we did is we migrated to purpose-built databases, Amazon Aurora, Amazon RDS, Amazon DynamoDB, Elasticache, Amazon Redshift. Not only did we reduce the database cost by 60% and reduce the administrative overhead by 70%, but we had a 40% increase in performance for some of our most critical applications. That is the power of moving your databases to the right purpose-built data store that we have in AWS. And let's stay on the data topic for a moment. Customers do want more value from their data, right? The data is exponentially growing. We have more and more sources, social media, mobile phones, IoT sensors, online platforms, ERP systems, all over the place in different structures, structured, unstructured formats, image, video, material. All of these different data points can help us greatly build better, more personalized customer experience, or maybe streamline our business. Now, traditionally, if we think about how we handle data, the idea was to say, let's build a data warehouse. That's not great because it creates data silos, right? You have your ERP, your CRM system, and you move it in your data warehouse, maybe include some social or sensor data. But now it's stored in that rigid, structured data warehouse, which isn't great because this doesn't scale very well, and it doesn't allow us to easily extract more information, especially from unstructured data. So over the years, a lot of customers moved away from that traditional data warehouse approach towards a data lake approach. And that has proven so successful that lots and lots of our customers are running their data lake on top of AWS. As a matter of fact, there are more data lakes that are running on AWS than any other cloud provider out there. No matter if it's Roblox or NTT Docomo or Comcast or Mozilla Foundation or ANA or Redfin or Duolingo or Airbnb, Coursera, you name it. All these customers are basically looking into building out data lakes on top of AWS. Why is that though? I mean, that data lake architecture is greatly beneficial to build scalable data lakes, especially when you run it on top of AWS. So you can have a nice integration into your data stores, your relational and non-relational databases, and then layer big data and analytics and machine learning on top of it. With the help of AWS, this obviously seamlessly scales. You have seamless data movement also for in and out of that data lake and unified governance. What does that specifically mean when we talk service specifically? Well, your data lake would probably run on Amazon S3. You can easily create it with the help of AWS Lake Formation and AWS Glue to do your transformation jobs on top of it. Obviously, that it integrates with Amazon EMR or Elasticsearch service or Amazon Redshift or Amazon Athena to run your queries on top of that lake, or Amazon SageMaker for your machine learning needs. The key point here is this: we have lots of different analytics and machine learning building blocks that now nicely integrate into that data lake that you built on top of AWS. But let's stick with machine learning here for a moment. What if we talk machine learning and AI, artificial intelligence? Again, the idea here for AWS is to say, let's take a three-layered approach. Let's take the top layer where we say we create completely fully managed artificial intelligence services that you can integrate into your application using APIs or SDKs. Things like computer vision or natural language processing or search or chatbot functionalities or health or industrial AI capabilities, anomaly detections. Or take things like personalization or forecasting or fraud detection. With Amazon Personalize, Amazon Forecast, and Amazon Fraud Detector, you get access to the same engines that Amazon.com is using for personalization, forecasting, and fraud detection. And all you need to do is you integrate it into your platform, connect it to your data sources, and off you go. No machine learning expertise required. What if you want to build your own machine learning models? Well, that's the middle layer. Amazon SageMaker is a full platform that allows you to train, deploy, and manage your machine learning models. Choose from pre-built algorithms or even an entire marketplace of algorithms that can be trained on top of your data sets safely within your environments. And lastly, the bottom layer is really about how can we make sure that we give you full flexibility and choice in terms of the framework that you want to use, no matter if it's TensorFlow or MXNet or PyTorch or Gluon or Keras or Deep Graph Library. You have full flexibility and choice in these frameworks. And like I mentioned earlier, also on the infrastructure side, not only do we give you a choice around the processes that we have and the underlying servers, but we constantly improve on how we can reduce the cost of training, but also running machine learning models on top of the AWS platform. But let's have a look. When I say these fully managed AI services here at the top, let's have a quick look on what I really mean with it's really easy to use and just an API call away. So what I'm going to do next is I'm going to choose Amazon Recognition, which is one of our computer vision services. I'm going to try to run it out of my console here. So let me switch over to my AWS Management Console right over here. So this is always a great way to kind of get started. And if I scroll down here, you can see we have the different machine learning services here, lots of different choices. So I'm going to choose Amazon Recognition, which allows me to run computer vision. And so we can do things such as object and scene detection, for example. You can see I do it here in the browser, but you can obviously integrate that into your application using an API call. So a picture like this could be analyzed and we understand, okay, I see cars, I see vehicles, transportation, and it also does an object detection. Here's a wheel, here's a car, here's a skateboard, here's a person, etc. Now let me try to make that call myself again from the browser. So I'm going to take the picture here of the palace in Seoul that I took the last time I was still able to travel there and see what happens if I send that to the fully managed AI here. And you can see it identifies people, humans, architectures, building, temple, palace. There's some clothing involved, right? And then you can also see it detected the different object detections. So every person here was nicely lined out and identified. We can also obviously do facial analysis. And by the way, celebrity recognition is also one part of this. Now, I wanted to point this out because this works also really well on Korean celebrities. Recently, I watched Sweet Home on Netflix, which was a great production between Korean and American directors that did a fantastic, interesting series here. One of the actors in there was Kim Sang-ho. You can see it works seamlessly well also on Korean actors. But by the way, talking about facial recognition analysis and these things, last year a lot of our customers have asked us, could you help, for example, to detect personal protective equipment, PPE, like masks or hand covers, etc. And that's one of the functionalities that we, again, just rolled out last year that allow us to say, for example, what if I'm wearing a mask? Here's a picture of me wearing a mask. Let's see if I send that to the AI service here, what's happening here. Okay, this person is wearing a face cover, and you also can see down here the face is covering the nose. Now, what if I try to trick it? So I'm going to try to move my mask slightly under my nose, see what's happening here, and see it's analyzing it. Yep, I'm wearing a face cover. However, I'm not covering the nose properly. By the way, PPE is super useful also for construction sites, as you can see in those sample images. So I figured, let me try that out also. Sometimes I go rock climbing. This is in Sheko in Hong Kong, where I'm currently based here. And see what happens here. If I do PPE detection, again, send it against the AI. You can see it identified the head cover, identified my hand covers out here nicely. Just an API call away, nicely being able to integrate into your application. And here you can really see the power of these fully managed AI services. Now, these were simple examples of just computer vision examples, but there obviously you have the full-fledged amount of different AI services that you can integrate. But on the topic of computer vision, by the way, we also looking into how can we bring computer vision closer to the edge. A lot of our customers have said, hey, it's great to run computer vision in an AWS region, but sometimes I have cameras hanging around and I run computer vision on top of it. Well, that's why we launched AWS Panorama, which is an appliance and an SDK that allows you to take existing CCTV or IPTV cameras and then plug them into this box and run computer vision at the edge. Why would we do that? Well, it allows us to maybe get better retail insights or look into workplace safety, social distancing monitoring, or supply chain efficiency. Or let's talk about manufacturing. With Amazon Lookout for Vision, you can give us pictures of defects on your products, and then the machine learning model will learn from it with as few as 30 images and will realize, okay, here are some defects or anomalies using computer vision. Again, we're trying to further democratize the space and make these technologies available for anyone to use. Now, the last thing that I wanted to address is how can we build modern applications that are resilient? And our CTO, Werner Vogels, always likes to say, failures are given, and everything will fail eventually over time. Why does he say that? Well, the idea here is basically, if we think that stuff can fail, we design with failure in mind. And if we do that, we can improve the resiliency of an application. But let's dive into that for a moment. Okay, let's say I want to achieve a 99.99% availability on an application. And let's say that application is built out of 1,000 different components. That means that either I need to achieve a 99.9999% availability on each of those dependencies, which is very hard to achieve, or I could say I try to isolate for independence. That means that if some parts of my system breaks, not my entire system will break. I just degrade the performance or degrade the experience. And that's really what we often refer to as try to limit the blast radius if something fails. And that is really modern application design. We limit that blast radius. We use architectural patterns such as circuit breakers or bulkheads, where you degrade the performance if something breaks. Take an example. If you watch Netflix, you open it on your TV, you always get this little catalog of saying, here are things that you probably also want to watch. That's coming from a machine learning model that learns on what it wants to personalize from you. What if that service breaks? Should we just not allow Netflix to stream anything at all? No, of course not. We load up the latest cached results. That is a degraded performance. And that's how you want to design your architectures, with the idea in mind of some parts can break, and those we can degrade the performance on it or the experience. And for some parts of my applications, they're so crucial that if it breaks, the entire user experience breaks. So those we over-invest time in making them highly available as much as we can. Now, with that in mind, though, another strategy that we want to adopt is to say, instead of thinking in the old traditional way of saying, if disaster strikes, we try to do a DR, disaster recovery, What if we try to preemptively find problems before they happen? That's the idea of chaos engineering. So the discipline of experimenting in distributed systems, and you go and you break things on purpose so that you can build the confidence in understanding when something breaks, well, how does my system recover? And if it doesn't recover automatically, now I can improve it, right? And that allows me to increase the resiliency of my environment. Take a few examples. Let's say I want to check what happens if my relational database starts to degrade in performance or breaks. Amazon Aurora allows you to, for example, simulate a system failure. You can have a certain percentage of system failure that you inject in your replicas, and then you can see how your system reacts. What if you run on Kubernetes? Maybe then you want to use Gremlin. Gremlin allows you to run a daemon on each of your Kubernetes node that tries to go break and block network access or do a node failure, and then you can see how your system reacts. And based on that, maybe make improvements to your architectures so that it recovers better from those failures or doesn't have these failures in the first place. A lot of our customers have told us, hey, chaos engineering, great strategy for me to find problems in my system. Can you help me do that even better? Can you help me with a service? And that's the reason why we launched the AWS Fault Injection Simulator. And the Fault Injection Simulator, as the name indicates, tries to break things on purpose with experiments that you run. So you can say, go degrade some of the performance, go turn off some services across the AWS service portfolio, and then see how my system reacts with CloudWatch alarms, Event Bridge, etc., send back and stop the experiment, and then monitor and see how it reacted on top of it. Again, a great way to preemptively find problems before they occur and make your entire environment more resilient. Now, to close up here, really, if you think about application modernization, it is really a step-by-step process, right? You want to use event-driven architectures that allows you to integrate maybe some of more of your legacy component to some of the newest microservices that you're building out. And the event-driven architecture allows for that to work. If you start replatforming or build new services, always use the right tool for the job. Look into the right purpose-built database that is suitable for the workload that you're building. And then leverage, of course, the power of data and machine learning services that are out there. Look into how you can go more and more towards serverless so that you can design for scale and availability without the need to manage that yourself, which, of course, is the last point here. Let AWS do the heavy lifting for you. Look into our fully managed services so that you can focus on building what's core to your business, focus on building your code, your software, and let us maintain and scale things out for you out there fully managed through the AWS platform. Now, lastly, I want to remind you that we always want to collect our customers' feedback, so please let us know after this session and all the other sessions that you attend today what you thought about it, what we can do better, so that we can learn from it and improve the experience for you. Now, with that in mind, I want to thank you again very much for your attention, and I hope you have a good day of the AWS Summit Online in Korea here. Thank you.